What do you mean? When you nod your head yes.
Hi, my name is Kelly. I'm in grade 10N, and today I'll be talking about the big project for math, and that would be standard reflection. So this is what we've learned in the past, like in the past quarter too, right? But this is not the only thing that we were supposed to do a standard reflection on. We did everything from the beginning of quarter one until now. So the first standard that we took in quarter one was ASSE2, being able to write one expression in a different form or ways. These are the ways that it's written. So basically, it's gonna be given to us in one form, and then we have to write it in a different form. So a plus b in brackets multiplied by a minus b in brackets equals a squared plus b squared. So that's what it translates into. Another one is a plus b in brackets to the power of 2 equals a squared plus b squared. Another one would be a minus b squared equals a squared plus b squared. So we also learn how to be able to factorize them and to see if it's like possible to even factorize them. So this is one of the examples that I did. Negative 2 in brackets, negative 2 in brackets x minus 1 in brackets 2x plus 3 equals negative 2x plus 2 in brackets 2x plus 3 in brackets. Negative 4, the answer to that translates into negative 4x squared minus 6x plus 4x minus 6. And we have to simplify this form, and the final answer would be 4x to the power of 2 minus 2x minus 6. The next standard is SSE3. This standard is writing the equation in an equivalent form and explaining the number represented by the expression. So the example that I chose is x in brackets negative 5x plus 325. And we have to write this in an equivalent form. An equivalent form is basically the same, it means the same thing, but it's written in a different way. So the answer is negative 5x squared plus 335x plus 335x. The next standard is SSE3A. The standard is about factoring the equations to show the zeros, the functions, and what they define as. The example I chose is y equals x squared plus x minus 6. So we have to write it as 0 equals to find the zeros later on. Y equals x squared plus x minus 6. 0 equals x squared plus x minus 6. And then we factorize it. After we factorize it, the answer will be x plus 3 in brackets and x minus 2 in brackets. So when we solve both of those equations separately, it will equal to 0. So 0 equals x plus 3. When we bring 3 to the other side, it will be 0 minus 3, and x will be negative 3. The next one is 0 equals x minus 2. When we bring negative 2 to the other side, it will be positive 2, which will make x 2. Let's go to the next standard. The next standard is SSE3B. This one is solving the quadratic equations by complete the square to find the maximum or the minimum of a value of the function. Basically, we can see that this is about quadratic equations. So we have to write it as f of x equals x squared minus 4x minus 6. So it's solve for f of x. Then we have to bring all the numbers on one side, and then on the next step we have to write f of x. We have to write it as f of x equals. So it'll be f of x equals x squared minus 4x minus 6. That's actually the way the question is given to us. So we can replace f of x by y, and now we start solving it. So the first thing we do is bring the negative 6 to the other side, which will make it y plus 6 equals x squared minus 4x. And now we have to take from the other side, there's negative 4x, right? We have to take that and divide it by 2 and do it to the power of 2. I accidentally wrote 4 here, but it's supposed to be negative 4. Anyways, negative 4 divided by 2 will be negative 2, and negative 2 to the power of 2 will become 4. So now we take 4 and we add 4 to both sides. like I wrote over here. We add 4 to both sides, and so y plus 6 plus 4 equals x squared plus 4x plus 4. That's what we end up with. And then we have to simplify this, which will be y plus 10 equals x minus 2 to the power of 2. So the reason why it's x minus 2 to the power of 2 is because we simplified, we factorized. We factorized x squared minus 4x plus 4.
This next standard is SSE3C. The standard is about how to manually find the interest rate over an amount of time, or to find how much money you'll have after a period of time. So this is the function that we use. It's a 1.15 to the power of 1 over 12 in brackets to the power of 12t. So that'll be 1.012 to the power of 12t. The example I did is if you deposit $4,000 into an account paying 6% annual interest compounded quarterly, how much money will be in the account after 5 years? So PV is the money that you deposit now. 6% is the annual interest that the bank gives you. 4 is for quarterly because 4 means like 1 over 4. So n equals 4. And T is 5 because it's the time, it's the amount of year. So FV is like the payment, right? So the function that we use is FV equals PV in brackets 1 plus R over n in brackets t times n. So we put the equations that we have inside, and it will be 4 in brackets 1 plus 0.06 over 4 to the power of 5 times 4. So we can see this, so we can graph this and see the answer. So I have it graphed over here. So this is the amount of growth, and 5, this is the amount of growth, and 5 is marked because it keeps growing, but in the 5th year it shows the amount of money that you'll have. Let's go to the next standard. So the next few standards are about arithmetics with polynomials and rational expressions. So the next standard is APR1. It's simplifying polynomials into quadratics to do addition and subtraction with them. So basically, the question will tell you what each letter is. So in my question, P equals x squared plus 3x minus 4, and Q equals x plus 5. So what I'm going to do is add those two values, and when I add them, I have to add what they stand for. So I add x to the power of 2 plus 3x minus 4 plus x plus 5. My result will be x squared plus 4x plus 1. What we do is that we add the ones with the square in them, the ones with the square on them, which is x squared. It's the only one, so we take it down right away. And then there's 3x and x, so we add those two. And then there's the numbers with no variables, and we add those. So yeah, the final answer would be x squared plus 4x plus 1. The next standard is reasoning with equations and inequalities. It's AREI 4. In the standard, I learned to solve quadratic equations, complete the square and the quadratic formula. This is the quadratic formula. X equals negative b plus minus square root of b squared minus 4ac over 2a. The example I chose is f of x equals negative x to the power of 2 plus 3x plus 4. So basically now we have to multiply everything by negative to make negative x squared a positive. When we do that, it will be x squared minus 3x minus 4 equals 0. The reason we do equals 0 is because usually we do it as equals 0 whenever we do complete the square. We then take negative 4 to the other side, which will make it positive 4, and so it'll be x squared minus 3x equals 4. So now we have to take 3x, and we have to multiply 3 by its we have to divide 3 by 2 and make it to the power of 2. And then after we do that, we take that value and we add it to the first one and to both sides basically. So the result will be x squared minus 3x plus 9 over 4 equals 4 plus 9 over 4. And we have to do 4 plus 9 over 4, and we can't just normally add it. We have to make the denominator and the numerator the same. So it'll be 4 over 1 plus 9 over 4 equals 4 times 4 over 1 over 4. So then that will be 16 over 4 plus 9 over 4, and the answer will be 12, and the answer will be 25 over 4. Then we take this one, then we take the answer 25 over 4, and we put it into square root, and we put the other part as well into square root to cancel the power of 2 of x. So it'll be square root of x minus 3 over 2 in brackets to the power of 2 equals square root of 25 over 4. Now we've gotten rid of the power of 2 of x, so it's x minus 3 over 2 equals square root of 25 over 4. Now we have to move negative 3 over 2 to the other side to find what x is. So it'll be x equals negative 2 plus or minus 5 over 2. And we got rid of the square root by simplifying 25 over 4. Not by simplifying it, but finding the square root of 25 over 4. So the square root of 25 is 5, and the square root of 4 is 2. So then we wrote x equals 3 over 2 plus minus 5 over 2. X equals 8 minus 2 equals negative 4 will be the answer after it's been simplified. So this is the answer when it's added, and this is the answer when it's subtracted. The next standard is ARE 4A. I learned how to solve a quadratic equation using the method of complete the square into an equation form of x minus p to the power of 2 equals q, and have the same solution to get the quadratic formula form of this form. F of x equals 4x squared minus 16x minus 32. So we have to make this equal to 0, and after we've done that, we have to divide everything by 4 so that 4x squared will become just x squared. So after we've done that, it will be x squared minus 4x minus 8 equals 0. Then we move 8 to the other side, so it'll be x squared minus 4x equals 8. And we add 4 to both sides because we take this 4, divided by 2, and put it to the power of 2. Put the value of 4 over 2 to the power of 2. Then it will be x squared minus 4x plus 4 equals 8 plus 4. Then we have to simplify that. It will be x squared minus 4x plus 4 equals to 12. We have to get rid of x squared, not x squared, but the square in x. So we put it as square root of x minus 2 in brackets to the power of 2 equals square root of 12. Because if we put one side into a square root, we have to put the other side into a square root as well. So it will be x minus 2 equals square root of 12, because we haven't gotten rid of, or we can't get rid of the square root of 12 unless there's the square root number. We can't get rid of square root of 12 unless we find the square root of 12, and we can't do that. So x minus 2 square root of 12. So we have to move negative 2 to the other side. It will be x equals 2 plus minus square root of 12. X equals 2 plus minus square root of 3 times 4. So x will equal 2 plus minus 2 to the square root of 3. So the reason that we did 3 times 4 is because 12 doesn't have a square root, so we multiplied by two numbers that one might have a square root or both might have a square root. So we found 3 times 4. 4 has a square root, but 3 doesn't. So we leave 3 in the square root, but we take 4 out as 2. So the final result will be x equals 2 plus minus 2 square root 3. Square root of 3. So the next standard is ARE 4B. In this standard, I've learned what the easier way to solve a quadratic equation is, and being able to recognize the answers by taking square roots, completing the square, the quadratic formula, and factoring. So this is the equation that I chose to do. This is the equation that I chose to do my example for. So My question is ax squared plus 7x plus x equals 0. So I have to factorize this, and when it's factorized, it will be x plus 2 in brackets, x plus 5 in brackets equals 0. And then we have to make sure that like each one is actually the value of 0. So x plus 2 equals 0 because when we move positive 2 to the other side, it will become negative 2, and the answer will be x minus 2. And then this one we do the same thing basically, except we do it with 5. So we move a positive 5 to the other side, it will become negative 5, so x will be negative 5. The next standard is AREI 7. In this standard, I learned to solve a system of a linear equation and quadratic equation and graph them. For example, finding the point of intersection between the line y equals negative x and circle x squared plus y squared equals 3. So for example, finding the point of intersection between the line y equals 3x and the circle x squared plus y squared equals 3. This is the question that I chose. Y equals x squared plus 8 and y equals x plus 10. So we have to make it equal to each other, so it'll be x squared plus 8 equals x plus 8. It'll be x squared plus 8 equals x plus 10. We have to move everything on one side. So it'll be x squared plus 8 minus x minus 10 equals 0. X squared minus x minus 2 equals 0 will be the simplified form because we minus the numbers and we minus the numbers together, and then we subtract 8 from 10 and we bring negative 2. We subtract 8 from negative 10 and we'll bring negative 2, and x plus square will come down immediately, so we'll negative 5. So we have to simplify this form. We have to factorize this form, and it will be in brackets x plus 2 in brackets x minus 2. That will equal 0. Then we have to actually find out if that's true. We move positive 1 into we move positive 1 to the other side to make it negative 1, and that will the answer will show that x equals negative 1. And then x minus 2 equals 0. We'll move negative 2 to the other side. That will be positive 2. So x will equal 2. This is the graph. So there's the graph of x squared plus 8 that's represented by the red one, and there's a graph of x plus 10 that's represented with the blue one. So as we can see that we were right because it says x equals negative 1 and then x equals 2, so the place where the parabola intersects the line will be negative 1 and 2. Moving on, FIF7A FIF7A is about graphing linear and quadratic functions and showing their intercepts, maxima and minima. We did this by hand, like we did it in class. So I just put some pictures from my notebook, and these are them. It's basically like graphing it on Desmos, but you do it by your hand, and we kind of use the same process. So yeah, this is for the linear, and this one is for the parabola, which is the quadratic equation. This is more of what we did. So let me just take one linear and one quadratic, and I'll explain it. So it's not really. So this is the linear. The question is y equals 5x plus 4. So 4 is the y-intercept. Okay, I'll cut this part out. So yeah, that is it. It wasn't really hard. One thing about the One thing about the making like the quadratic equations by hand is we have to use the quadratic formula, which is negative b over 2a plus minus to the power of. One thing that's different about the graphing the one thing that's different about graphing the quadratic equation by hand is we have to use the quadratic formula. I stated this earlier when I was talking about another standard. The quadratic formula is negative b plus minus square root of b squared minus 4ac over 2a. So we use those. So we use that formula to. We use the beginning of that formula to do this, and then to find like the side of each parabola to find one half of the parabola. We use the second part of the quadratic equation. The next formula, the next standard is FIF8A. So FIF8 is basically about writing a function and defining by. The next standard is FIF8. It's writing a function and defined by an expression in different but equivalent form to reveal and explain different properties of the function. So the reason I didn't do this one is because like FIF8, FIF8A, FIF8B, it's kind of similar, so I just did FIF8. So in FIF8, we learn to factor and complete the square in a quadratic equation and show the zeros and extreme values. So FIF8 is kind of similar to SSE2, so I didn't actually do it. It's basically writing expressions in a different or equivalent form and reveal and explain the different properties of the functions. The next standard is FIF8A. In the standard, we learn to factor and complete the square in a quadratic function and show the zeros, extreme values, and system. And this in the next standard is FIF8A. We learn to factor and complete the square in a quadratic function and show the zeros, extreme values, and symmetric. And this FIF8A is the next standard. In this standard, we learn to factor and complete the square in a quadratic function and show the zeros and extreme values and symmetry of the graph and interpret them in the context. We use the quadratic equation again, but in this we only use the beginning part, which is negative b over 2a, and this is the full formula. So we need to put it in the form of x and y, we need to put in the form of coordinates, which is xy. So the question is y equals 2x squared minus 2x plus 4. X equals negative. So first we write the formula, which is x equals negative b over 2a equals 12 over 4 equals 3. And that is the formula, and now we go into solving the problem. So it'll be y equals a in brackets negative b over 2a in brackets 2 minus b in brackets negative b over a plus c. This is also the formula that we actually solved the whole thing into. So here's the actual answer of the question that we're given. So it's y equals 2 in brackets 3 to the power of 2 minus 12 in brackets 3 plus 4. So 3 is the answer of 12 over 4, so it'll be 2 times 9 to the power of 2, and negative 26 plus 4 to the power of 2 again. No. So it'll be y equals 2 in brackets. So it'll be y equals 2 in brackets 2 minus 12 in brackets 3 plus 4. And the answer of all this would be y equals 2 times 9. Y equals 2 times 9 equals 36 plus 4. And we solve this, it'll be 18 minus 32. We have to simplify this, and the answer would be y equals negative 14. And so so the answer will be y equals negative 14. So the coordinates will be 3 and 14, because x over here, when we found it, it's 3, and then y over here, when we found it, it's 14. So the coordinates will be 3 and 14. X will be 3 and y will be 14. So the next few standards are NRN, which is extending the properties of exponents to rational exponents. They're about the real number system. So when we learned about this, it was combined. I kind of tried to separate them, but I'm not sure if it worked out pretty well. I kind of tried to separate them though. When we learned about this, it was kind of combined, but I kind of tried to separate it. NRN1 is about explaining how the meaning of rational exponents follows from extending the properties of integers exponents of those values, allowing for a notion for radicals to terms of rational exponents. For example, we define 5 1 over 3 to be the cube root of 5 because we want 5 1 over 3 to the power of 3 equals 5 in brackets 1 over 3 to the power of 3 to hold. So 5 in brackets 5 1 over 3 in brackets to the power of 3 must equal 5. So it's pretty explained at the example. I just realized that the example I gave doesn't really explain it well. So yeah, the example that you have given actually explains it well. It's basically we multiply 5 to the power of 3. We multiply 5 with 1 over 3, and then we power that we power the answer by 3, and so basically the final answer that comes out of that will equal 5. The next standard is NRN2. In this standard, I learned how to rewrite expressions using radicals and rational exponents and the properties of exponents. So it's 5 over 3 equals 2. Square root of 8 to the power of 5 equals 2 to the power of 5. Basically, the denominator goes over here on the beginning, and the numerator goes in the end. What we do is we find the square root of the second place, which will be 4, and we find the square root of the second place, which will be 2, and so we find the square root of the second place, which is the same thing as the square. So basically we find the square root of the third place, which is basically 2, and we do 2 to the power of 5, and the result will be the answer. The next standard is NRN3. In this standard, I learned why the product of two rational numbers is a rational number, and why the sum of a rational number and an irrational number is an irrational number, and that the product of a non-zero rational number and an irrational number is irrational. First, let me just explain what a rational number is. A rational number is a number that can be written as a ratio. So this means that it can be written as a fraction, and both the numerator, the top part, and the denominator, the bottom number, are a whole number. So the question is 4 to the power of 7 over 7. In this one, 7 and 7 are the same, so it won't really be confused where it goes, but the numerator goes over here and the denominator goes over here. 49 to the square root of the 7. It'll be 7, and 7 to the power of 7 is 49. The next 2 to 3 standards are about the complex number system. In the standard NCN1, we have to know that I is an imaginary number, and we can replace a number with that and solve complex numbers to become in the form of a plus bi, and a and b are real numbers. These two exercises are from one of the exercises we did in class. So this is the first question. So the question is 3 plus 7 plus 8i, and it asks for the answer. This is a pretty simple question, but I thought that it works the same way with the other questions as well, so I took it. Basically, we add 3 and 7, and it will be 10, and then we take 8i and we'll put the same value because it doesn't add with anything because it has I in it. The next standard is NCN2. In this standard, we use I squared, which is -1, and add and subtract multiple complex numbers. So the example I used is square root of -49. So usually we can't actually find the square root of -49. We can't find the square root of any negative numbers. The question I chose is what is the square root of -49? So as we know, a negative number we cannot find the square root of a negative number, because when a negative number is multiplied by itself and it's a negative number, it'll be -7 times -7 is 49, and 7 times 7 is 49. So what we do is, so this is why we're going to use I, the imaginary number. So first of all, we take I, which is -1, and we multiply it by 49. So we took the negative separately and we made it as -1. So then we find the square root of 49, which is 7. So the answer will be 7 to the square root of -1 equals 7i, because I is the same thing as -1. So the last standard is NCN7. In this standard, we solve quadratic equations with real coefficients. In this standard, we solve quadratic equations with real coefficients that have complex solutions. So the question I chose is square root of -5. It's basically the same idea. It cannot be solved on its own, so we replace negative with -1, so we multiply it with itself, and the answer will be I to the square root of 5. Yeah, that is pretty much all the standards that we have taken in quarter 1 and quarter 2. Some of them are closely related, others aren't, but I'm pretty sure that I actually learned something new and that I remember stuff from it, and that makes me happy. And I think that I could use this in real life, because the big project we did, actually, it relates what we've learned with real life, like with measuring the water fountain, and the one I did myself was a rainbow. So I hope I explained it all well, and it made sense, and yeah.
What do you mean? Oh, when you nod your head yes,